Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in MCR 3U who are studying for the final exam. This is video number 5 and we start here with question 19. It says identify the parameters and use them to describe the transformations that must be applied to the graph of each base function to obtain the transformed function. Write the transformed function equation in simplified form. So here's the base function, it's the root function. And then what we want to do to it is all of this stuff over here. So what do we know? Well, we know that this negative value, so a is -1. So it hasn't been stretched or compressed vertically, but it has been reflected vertically. And that means a reflection in the x-axis or over the x-axis. I don't know. It depends on what your teacher said, I guess. Then we have a k value of 4, and that means a horizontal compression by a quarter. So again, the inside stuff, so anything inside the bracket is sort of the reverse of what you see. I see 4, so I know that means a quarter. Similarly, I see +3, so that means I'm actually going left by 3. So this, d equals -3. Do I say that? Yeah. So this is a phase shift, or I guess just horizontal translation, 3 to the left. And then finally over here, this is a vertical translation. Hope you're not trying to read my writing, you're just listening to my voice, right? This is a vertical translation down 1. So this is c equals -1. So we know that we are reflecting it in the x-axis, horizontal compression by a quarter, left 3, down 1. So to write the proper function, so using the square root, so y equals negative. Now anything that affects horizontal, so for example, the horizontal translation to the left and the horizontal compression have to happen inside the function. So within the square root sign, I have to indicate that we did a that we want to horizontally compress by a factor of a quarter, and we want to move 3 units to the left. So both of those are inside the square root sign, and then down 1. So that's what my answer would look like. So again, it looks very much like the original y equals f at x. You just have to remember what goes inside and what goes outside. So let's do something similar with part B. Excuse me. This time the base function is 1 over x. So now we have a vertical compression by a factor of a half. We have a reflection in the y-axis. We have a movement to the left by 5 and a movement up 2. So again, we have a horizontal compression by a factor of a half, up 2. So these two don't change. They're exactly what you see. This negative sign means reflection in the y-axis, and then left 5. So you could write that all down, and then so the equation would actually look like this. So 1/2, and then 1 over. So the inside stuff looks like this. So the 1/2 and the +2, the vertical changes occur outside the function. The function itself happens at the bottom of this fraction. So that's where you see this negative and this plus. So this is why we have to write it in simplified form. This is definitely not simplified form. Y equals 1/2. So I have y equals, so the first thing I'm going to do is I'm going to take this negative and I'm going to move it up because I don't like seeing a negative on the bottom of a fraction. So now we have a multiplication happening here. So remember, when you multiply fractions, top times the top, bottom times the bottom, and then this +2 on the edge, we're just going to leave it there. We could talk about getting a common denominator, but this is perfectly fine. This also tells us exactly what we have to do with our function, so we're going to leave it like that. So let's go on and look at question 20 because it's similar, just kind of the opposite. In this case, we're given the graph of a function and we need to write the base function and the transformed function. So this function here, you should be familiar with it because if I put it where it's supposed to be, oops, I didn't curve it enough, whatever. 0, 0, 1, 1, 4, 2. Does that sound familiar? This is the equation y equals the square root of x. Now, it's supposed to be at 0, 0. This is not at 0, 0. So we've had both a horizontal and a vertical translation. So we've moved it to the right by 2, and we've moved it down 5. So we know what to do with those. Now, but a little tougher is to find out if it's been vertically stretched or not. So normally, from 0, 0, you go over 1, up 1, because the square root of 1 is 1. So from here, do I go over 1 and up 1? Yes, I do. That seems to suggest that I haven't stretched it at all. To confirm that, my next known point is the point here at over 4 up 2. So let's test and see if that point still exists. If I go from the basic start point over 4 and up 2, I still have a perfect graph. So I haven't stretched or compressed this graph at all. All I've done is moved it from original location. Then how did I move it? I moved it to the right by 2 and then down 5. So this is what right by 2 looks like, and this is what down 5 looks like. And then let's look at part B, same idea. So now we have what you should be familiar with is the 1 over x function, or the reciprocal function. So we know the base function looks like this. Now in the base function, the starting point is at 0, 0. In this case, the starting point is here. So we've had both a horizontal and a vertical movement. So we've moved to the right by 1, and we've moved up by 4. Now let's see if we've stretched or compressed it all. On the basic function, from the starting point, if you go over 1, you should go up 1. So over 1 and up 1, that seems pretty nice. Let's check. If I go over 2, I should go up a half. If I go over 2, do I go up a half? Yes. And I'll check that in the other direction. 1, 1, 2, a half. So again, I don't see any horizontal or vertical stretching in this graph. All I've done is moved it to the right and up. So what would that look like? So the change to the right has to happen inside the function. So that's what this looks like. And up 4 happens outside the function. So there's my transformed function. Right 1, up 4. Okay. So I'm going to stop this video here. That was questions 19 and 20. And if you want to keep going, I'll see you in the next video.